this video, we're going to take a look at how we can take square roots with variables. And to set this up, we'll remember an exponent property that if I have x to some power squared, we end up multiplying these exponents to get x to the 2a. This means if I want the square root of x to the 2a, we want to know what squared is x to the 2a? Well, it was x to the a. Notice we could get this result by taking the exponent and dividing out the 2. We divided by 2 on the exponent when taking the square root. This is the opposite of multiplying by 2 when we squared the exponent. So let's take a look at how this would work out with a couple examples. First, in this problem, we have negative 15 times the square root. Actually, let's make that negative 5. Negative 5 times the square root of 18, x to the 4th, y to the 6th, z to the 10th. First, let's look at the 18. We know we can simplify the square root of the 18 by factoring it to 2 times 9, and then finally 3 times 3. And then we know we've got a couple pairs. We've got a pair of 3's, and so we'll, with the negative 5 out front, don't lose that, times pair of 3's, we pull 1 3 out of the radical. When it comes to the variables, what we will do is we will divide the exponents by 2 when taking a square root. X to the 4th. 4 divided by 2 is 2, so we have x squared on the outside. On the y to the 6th, 6 divided by 2 is 3, and so we have y cubed on the outside. Continuing to divide the exponent by 2, 10 divided by 2 is 5, and so we have z to the 5th on the outside. The only thing left inside the radical that has not come out is the 2. Finish up by multiplying negative 5 times 3 to get negative 15, x squared, y cubed, z to the 5th, times the square root of 2 for our final answer. As we work, sometimes we won't be able to divide the exponents by 2 evenly. If that's the case, the remainder will remain inside the radical as a leftover, just like the 2 remained inside when it didn't have a match. So looking at the second example here, the square root of 20, x to the 5th, y to the 9th, z to the 6th, we'll first look at the 20 by factoring it. 2 times 10, and finally 2 times 5. We see we have a pair of 2's, and so that will allow a 2 to come outside of the radical. Next, we have x to the 5th. When we divide 5 by 2, we get 2 with a remainder of 1. That means 2 come out, and 1 remains inside the radical. We'll say x to the 1st. 2, remainder 1, inside the radical. Similarly, the 9 divided by 2 is 4 remainder 1. So we've got y to the 4th with 1 y remaining inside. Z to the 6th, dividing 6 by 2, we get z cubed, with none remaining inside because there is no remainder. This means what we have left inside the radical is a 5, an x, and a y. With nothing to multiply, this becomes our final solution. 2x squared, y to the 4th, z cubed, times the square root of 5xy. Again, when taking a square root with variables, we divide the exponents by 2 to tell us how many come outside. If there's a remainder, that's how many will remain inside the radical.